length over here. That means that the perimeter of our semicircle is a half pi times the 6 meter diameter plus 6 meters. And so that's equal to 3 pi meters plus 6 meters. And so let's round this off. And so the perimeter of the semicircle is equal to approximately 15.42 meters.
We've been drifting, lost at sea. You're so far.
Bring the family together with great specials. Like 2 kg Sunlight hand washing powder for only $41.99 and Shield Roll-On deodorant for just $14.69.
I'll be your lighthouse and bring you back to me.
We're here for you.
And aggressive disease containment.
Now on lockdown.
It is one of the measures taken by the country.
How long is all this for? Scientists say that's the big question.
News that connects you globally, from the world to your home, with 4 leading news channels 24/7. Live breaking stories on GoTV. GoTV. Live it, love it.
We've been drifting, lost at sea. You're so far.
Bring the family together with great specials. Like 2 kg Sunlight hand washing powder for only $41.99 and Shield Roll-On deodorant for just $14.69.
I'll be your lighthouse and bring you back to me.
We're here for you.
And aggressive disease containment.
Now on lockdown.
It is one of the measures taken by the country.
How long is all this for? Scientists say that's the big question.
News that connects you globally, from the world to your home, with 4 leading news channels 24/7. Live breaking stories on GoTV. GoTV. Live it, love it.
This broadcast is made possible by the Capricorn Group.
Okay, so actually we did now all 4 new formulas on trigonometry. Okay, so let's just look at what we know already again in trigonometry. So this is in any triangle that we're looking at, and the first one is A over sine A is equal to B over sine B. Now, as long as I tell you this is the formula to use, then it's usually easy. But when we start mixing them, it gets a little bit more difficult. So I want us now to do Cambridge questions on this. Okay, so cosine A is then B squared plus C squared minus, in brackets, 2BC cosine A. And I think by now it's not so difficult anymore. is equal. So the side and the angle correlates. When do I use this one? When I want the third side. This is all about the third side. Then we also had this one, cosine A is equal to B squared plus C squared minus A squared. Again, the side that you subtract, and this one correlates, times 2BC. And the last one is this area one that we've learned now, and this one is half BC sine A. Make sure that you know them, because do you know what I get in the exam? This is where the sine goes, and this is where the cosine goes. You forget them, you get confused. So again, I would advise you to make flashcards and put it there where you are studying so that you can see them every time. I've read an article the other day about how to study. And then they said this method of flashcards is one of the ones that work very well. So if you make flashcards and you go through them. And another one is working out old question papers, because that's what I'm saying all the time. So that's it. Okay, so let's mark the area questions that we were busy with. And then we continue. We were busy on page 239, exercise 15.12. So what we said here is this is the two sides and the included angle. That's what's very important. This one is 10, that one is 40, and this one is 35. So and this is now easy because you just have those two sides. But once you've got more sides, it gets more and more difficult. So the area is going to be half BC sine A. So the half of 35 times 40 sine 10. 1 to 1.6. What did I say about the rounding? 1 decimal place. Usually it's 3 significant figures, but you must add here. Okay, then number D. This was now number 1C. And then number D. So the area is going to be a half of 6 times 8 sine 135, 17.0 centimeters. Okay. So that's that one. Now let's turn around to page 240. Calculate the value of x in each of the following. Give your answers correct to 1 decimal place. So this time they gave you the area. They asked it now in another way, and they gave you the area. So this is now number 2A. Let's do this one together. So area is still a half BC sine A. So the area, which is now 40 square centimeters, is equal to a half of 16 times 12 sine x, because that's what we need to calculate now. And this time it's the angle that we need to calculate. So I would first get, well, there's different ways now. You can multiply this in, or you can first get rid of this one. So it will be 40 times 2. Divide by the 16 times 12 is equal to sine x. And how are we going to get that value of x? Second function, sine. Second function. You must do this now in your books. Second function, sine. So it's still the same formula that we're dealing with. This time they just provided you with the area, and you have to find that angle now there. You have to find the angle. Right. So what is the answer? Second function sine. Yeah, the answer, you're going to second function it to find that angle. So the answer is to be the second function. Now you have to multiply that. Did you get a 60 there? Yeah, I got, because remember we said sine ranges between -1 and +1. So you'll have to put that whole thing in brackets. How I press my calculator, 40 times 2, divide by 16 times 12, and then second function, my answer. So the answer is then 24.6. Remember, angles is usually 1 decimal place. Angles to 1 decimal place. That's how we would deal with that. If you do this, I think you get 5/12. So then you just press shift sign. Okay, the next one is now number 2B. Number 2B, let's quickly do that one. Again, they provided with you with the area. So what is the formula? The area is half BC sine A, half BC sine A, and it will then be 20 is equal to a half of 9 times x. This time we want x to calculate this one, sine 160 degrees. So it's different variables that we need to find now here. Okay, so it's just about opposite operations. So this one will be 20 times 2 divide by 9 times sine 160, and this time you just want the side x. We just want to calculate that side x. It will round off to 13.0. Remember that you will actually always first write down that unrounded one, and then you round it off, because a lot of times we're going to use this unrounded one in the next one. You're going to use it then in the next situation there. Okay, then you can quickly do number C and D. So the next one is then now number C. So the area is half BC sine A, half BC sine A. The more you repeat it, the better you remember it. So 150 is equal to a half of 15 times x. Again, you want that side there, and it's sine 60 degrees. So what is x? Opposite operations. Yeah, 150 times 2, 15 times sine 60. Right, and then the last one, number D, and this one is then area, which is 50 is equal to 14 times 8, half of 14 times 8 sine x. So again, this one is going to be second, no, we want x, so second function sine, 50 times 2, divide by 14 times 8, second function sine. Right, now the new lesson today is to look at 3Ds. When we work with these in 3 dimensions. Now, look at my box here. So, I can calculate the area of this one, isn't it? By using Pythagoras or half base height, I can get it, or getting the lengths of the sides. The angles are 90 degrees, so this is basically with sine, cosine, and tan, the ones you did last year already. But now sometimes they're going to ask you to find this angle here. Can you see? So that means I first need to find the hypotenuse in this base, and then I can work with that one there. This is 3-dimensional ones. Now, the secret here is to always draw your little triangle so that you can see where is your 90 degrees. For instance, in this case, this is where my 90 degrees is here, to find that third dimension then there. Now, let's look in the textbook, because we'll have to look at examples there. They've drawn planes for you also there. But so now we're actually back to just sine, cosine, and tan. That's where you're going to use that. So on page 240, you will see there's a 3-dimensional cube. Can you see there's the cube? All the sides are 3 centimeters long. And now they say calculate EG. EG. Now, EG is like here, the base. This is the base that you're going to calculate there. So with Pythagoras, we're going to add, and the answer is then the square root of 18. You can get a value then there. Now they want AG. Now AG is this that I'm showing you here. Can you see? It's from the top to the bottom. That's 3 dimensions. Girls, this is what the boys understand better, and some of us struggle to see that third dimension then there. So look at, can you see that shaded one? That's the little triangle that I say. If you draw that one, it becomes very easy, but otherwise we get confused with which sides we are using. So you have AE, which is 3, and EG, which is now that one, is the square root of 18, and then you can calculate AG. Then we will add it again. And the third example there is to calculate the angle. So which function will it be? Tan, and then we get the angle. Just with Pythagoras, 3 squared plus 3 squared. They said 3 squared plus 3 squared to get that side, that hypotenuse there. But now the picture looks like this. So now it is in this triangle that I'm working. So this side is now the previous hypotenuse. And that one is then 3. So to get that one, it will be 3 squared plus the square root of 18, or you can get the value, it will be 4 point something then there. Okay, now calculate the length of HF. So if you look at that picture there, what will be HF? It's just the hypotenuse, isn't it? This is the third side in a right angle triangle. So this one is going to be the square root of 4 squared plus 4 squared, which is equal to what? Okay, that one is easy. But let's look now at HB. So now I'm going to draw my little triangle. I draw the triangle so that I can see what is going on. This is H, this is B. Now where is your 90 degrees now in that triangle? The 90 degrees will be where? F, yeah, at F. That is where it is. And we know now that HF, this is what you calculated there, HF is 5.66. And this one is 4. So to calculate HB, it is going to be, so this is now HB, and this one is going to be 4 squared plus 5.66 squared. 4 squared plus 5.66 squared. Right, and what do we get? 6.93. Okay, and then the last one says calculate angle BHG. Now again, if you look at that cube, it's difficult, but once we go to this one, the little triangle that you've drawn, it's easy, and we want to calculate BH but F. So this is the one that we want to calculate. So which function? You can actually use any function now here because you've got all the sides. I'm going to use tan. I usually go for the given information. So tan H is then 4 divided by 566. Second function tan, and we get the angle. 35.2 degrees. Okay. Right, I'm going to stop here. Trigonometry in any triangle, grade 11s. Let's finish up this part now here. So the first one was the sine rule. How does the sine rule go? A over sine A is equal to B over sine B. The one that you want to calculate comes in the left-hand corner. When will I use this? When I have opposite sides and opposite angles. The next one is the cosine rule. A squared is equal to B squared plus C squared. When do I use this one? For the third side. This is about the third side. Then the next one is if I want cosine A, then it will be B squared plus C squared minus A squared over 2BC. And the last one then that we had was the area rule, half BC sine A, three-dimensional trigonometry. So we said sometimes in a cube, then we want to calculate, first with Pythagoras calculate that side there, and then you want to calculate this third side or an angle. So that's how you work three-dimensionally with them. And the secret is to draw that little triangle every time. Draw the triangle that you want. So in the textbook now, if we look on page 240, 250, that is where we find them. And every time we first draw that right angle triangle. Obviously, Jean-Pierre, because this is a right angle triangle, cosine, sine, and tan is applicable again now here. Right, so we look at exercise 15.13. How far did we mark on Friday? We start? No, we did. A, B, and C. Okay, so let's just get those answers there. Exercise 15.13. This is then page 241 in the textbook. So again, the first is calculating HF. So HF is then 4 squared plus 4 squared, and I think, Albert, you said it's 5.66. Okay, now we have to calculate HB. Now look, now I'm going to draw that triangle. HB, where is my 90-degree angle? That's now very important at F. Can you see that? So that means HF is now 5.66. This one is still 4, so to calculate HB, it will be 4 squared plus 5.66 squared, which is what? 6.93. Remember that you will actually also use unrounded information there. And then we want angle BH, if I think we changed it there to BHF. So this is the angle that you want. And eventually at that point, you can use sine, cosine, or tan to calculate that angle. Well, it doesn't matter. So I'm going to say that tan H is then 4 over 5.66. And what was the size of H? 35.2 degrees. Tan, opposite over adjacent. Tan, there. Okay, I would like you now to do number 2 for me. And then the next one that I want you to do is number 5. They love one like number 5. So we're going to do number 2 and 5 now. First place number 2, but then also number 5. That square base pyramid, that is one that they love to ask.
The pandemic has hit.
There are 5 new cases.
Wash hands with soap and water.
Do whatever it takes.
It is in times like these that DSTV has you and your family covered with key international and African news channels.
Top stories impacting the finance and business world across West Africa.
India's financial institutions were causing concern.
Giving you insight and perspective from all angles when you need it most.
Polar ice sheets are losing 6 times as much ice.
African states have imposed restrictions on international travel.
Breaking news whenever and wherever it happens in real time.
The explosion that rocked the town on Sunday morning.
But what impact can it have?
Get all the world stories first, 24 hours a day, every day. Stay in touch, informed, and in the know with DSTV.
At trigonometry. This is then the last phase, and we're looking at the 3-dimensional trigonometry questions. And what we said is the secret is to draw that little triangle that you are working with and find out where's the 90 degrees. Then it's much easier to solve them there. Okay, so we're marking number 2 and 5. Those were the 2 questions that you did. Right, so question 2. Calculate the length of CA. Calculate the length of CA. So that's now on the top there. And obviously CA is going to be 5 squared plus 3 squared. It's on the top level that you calculated that one. Then the next one, calculate the length of CE. Now, I want to calculate AC. And if you can look at the base also, it's 5 and 3 on page 241. Now, the second one that you need to calculate now is what I showed you with this box, that now we have this one, or if you look there at the line, this is what you need to calculate now. So that's why we say first draw that little triangle then there. You have to calculate CE. Okay, now if we look at this one, first this is drawing my little triangle. We have to calculate CE. So CE, but my 90 degrees is at A. Can you see? So I have AC now, which is 5.83. You must just use unrounded information there, Leo. And then we know that AE is also 2 centimeters. 2 squared plus 5.83. Yeah, but we should go for 3 significant figures. No, they didn't say anything there. 5.16. And then calculate ACE. So it's still in that same triangle that we want. This is the one that you need to calculate. Can you see my little triangle helps a lot? And actually you can use any function just depending on the sides that you use. So I would say that side tan C is then equal to 2 over 5.83. Johannes, what was the angle here for C? 0.9 degrees. Okay, right, then the next one was on page 242, number 6, and I told you they love that one. That one with the square-based pyramid is almost in every paper, so that's why I've chosen that one. The diagram shows a right pyramid where A is vertically above X. Calculate the length of DB. Okay, so in the first place we're looking at DB then. Straightforward, it's on the base, so Jean-Pierre, it will be 4 squared plus 6 squared. What did you get? 7.21. Then we say calculate the angle DAX. So DAX. Now DAX, so I'm going to draw my little right angle triangle. DA, this one is D, and X is at the 90 degrees. Can you see? Now, dx will now be a half of that one, so it will be 3.61. I need to divide that one. Be careful for premature rounding. You must round off in final steps then there. And which other side do we have now? This one. The hypotenuse is 10. And you have to calculate CAX, this angle here, so I think we should use the sine function. So sine A is then equal to 3.61 over 10. You are nay. Second function sine, what is the size of A? 21.2 degrees. 21.2 degrees. Right, then the next one is number, okay, that was actually A2. Now we're at B1. Calculate the angle CED. CED. Okay, so that's on the base that we are working now there, CE or CED. So that's on the base. Which little triangle will you use now? Yeah, so let's draw that one. CDE, so I think the 90 degrees is now at D. The 90 degrees is at D. CE is the same as DB, which was 7.16. Okay, so you could choose now any function then here to use. Any of them we can use there. We have to calculate CED. This is the one. So I'm using tan again. So tan E is then equal to 4 over 6. It's always good